Hi students, now we are going to look at Rutherford's alpha scattering experiment. So first, you must know what is meant by the exact meaning of scattering, right? See, whenever the light rays from sunlight reaches the atmosphere of Earth, now the molecules present in the atmosphere will absorb the light radiation. That light radiation has got some frequency, right? After absorption, those light radiation will be emitted out again by the molecules present in the atmosphere. That process is what we call as the radiations are re-radiated out. And then the re-radiated radiations or rays were spreading or will spread throughout the atmosphere and scattered everywhere. Here, scattering means not only spreading, it means the radiation which has got a change in frequency than its original frequency. So after it has got re-radiated out by the molecules, it has been scattered. It means it has been scattered with different frequencies. This is what we call as a scattering of radiations. Now, here we are going to see a lead box which has a narrow hole, a pinpoint hole like that, inside which a source of alpha radiation is kept. What will be a source of alpha radiation? So any radioactive elements which produces the alpha ray. So example, radium, polonium, etc. Why did we choose the lead box? So why it is kept inside the lead box? See, whenever I keep a radioactive element, it will radiate out an alpha ray or radiation, right? The remaining part of the rays will be scattered inside, or we can say that it is totally internally reflected. That is, multiple reflections happens here, and these rays will be absorbed by the lead box, because lead prevents any hazardous damages produced by the radiations, right? It absorbs any radioactive radiations. Now, this is the ray, that is alpha ray. What is meant by alpha ray? It is nothing but 2He4. That is a helium particle, which is a positively charged particle, right? Here we are using two diaphragms, or sometimes one lead disc like that. So this will be looking like the ray will pass through these holes of these two diaphragms, which can be made of lead like that. Now, these rays pass through the two diaphragms T1, T2, and then made to incident on a gold foil, a thin sheet like material made of gold. Now, these rays, when pass through the gold foil, some events are happening, some phenomena are happening inside the gold foil, we will see. Then here, inside which some scattering is happening, those scattered radiation will come out in different direction, and here the scattered radiation will be incident on a screen called zinc sulfide screen or zinc sulfide coated screen. right? It's a fluorescent screen which is coated with zinc sulfide. So whenever the scattered radiation incident on this zinc sulfide screen, some tiny flashes of light will be produced. That tiny flashes of light will be seen through a microscope, right? A low power microscope is used there. Now, so what is happening inside the gold foil? Here, using this experiment, Rutherford has found in detail the structure of atom. The atoms consist of some electrons but with more gaps. The atom has a nucleus which has been the core of the atom, like that, which is completely a positively charged particle. That is, positively charged nucleus is there. And since we have a lot of gaps inside every atom, the light rays may able to penetrate and go straightly. Since we have got electrons there, the radiations here is the alpha ray, which is a positively charged ray, so they may get attracted towards the electron. So they may get deviated towards the electrons, some rays. And some rays will be scattered back because the central core of each atom has a gathering of positive charges like proton and neutron, that is, so due to which positive charge, the positive charge is repelled, right? So they are scattered back, and some ray a single ray at least we can say is retraced after reaching nearer to the nucleus of an atom. See, I said some rays are scattered back, some rays penetrates into. So whenever they penetrate straightly means there are some gaps present inside every atom, and they are scattered in different angles, means they have been attracted by the electrons, so they move towards the electrons, due to which they are getting deviated from the straight line direction. And they are scattered back means because the charge of the nucleus is positive and this is a positively charged radiation, so it would have been repelled back. And some ray or radiation would retrace back. If this is the nucleus, this ray has proceeded up to a point nearer to the nucleus and then retraces back. Why? Why does it happen? So whenever any particle is incident on a wall at an angle of 90 degrees, surely the particle will be retraced back, will come along the same direction, in the opposite direction, right? In which it has traveled. Now, this retrace happens. Maximum it can go up to this point and then it is getting retraced, means here this is the helium, that is Q1, this is the charge of the nucleus, that is Q2, which is nothing but Z into E, right? So here this is the distance which is called as R0, which is also later found was equal to the size of the nucleus. This R0 was later found as the size of the nucleus. So why it has got retraced? Since both are positively charged particle. Here the kinetic energy of the alpha particle is converted into the electrostatic potential energy at this point. Here the kinetic energy of the alpha particle has been converted into the electrostatic potential energy at this point, right? So the kinetic energy is equal to the electrostatic potential energy, right? That is of mv square is equal to the electrostatic potential energy 1 by 4 pi epsilon naught q1 q2 by r. Here I am going to change that as r naught. What is q1 q2? Here of mv square 1 by 4 pi epsilon naught, q1 is Ze, q2 is, that is q1 is 2e, I can say, q2 as Ze, anything. So this is 2e. Charge of nucleus, charge of the alpha particle by r naught. Now I am going to bring this r naught here. So 2Ze squared by 4 pi epsilon naught E suffix k. That is the kinetic energy has been brought out here as E suffix k, which is equal to of mv squared here. So this is the distance of closest approach. This r naught is called as distance of closest approach, which was later found to be the size of the nucleus, right? So this was how he has given the things about the alpha scattering experiment, and due to which in this experiment only he has found the complete atomic structure, right? And I think so you must have understood. Thank you.